Hello and welcome to Algebra 2. Today is Thursday, October 15th, and our topic for today is all operations on polynomials. So really what we're doing today is going over some more challenging examples of topics we've already covered, like addition, subtraction, multiplication, and division of rational functions, where a rational function is just a fraction. All right, let's dive into our first example. Make sure that you pause and write the original problem. All right, I see a division sign. So right off the bat, I'm just going to do a keep, change, flip and get that out of the way. So we're going to keep the first fraction exactly the same. We're going to change division to multiplication, and we're going to flip our second fraction. Okay, let's label these A, B, C, D. Okay, we'll make this first A yellow. Great. So for A, I have y squared plus 3y. We can factor out a common y and get y times y plus 3. And that's it, actually, for part A. Great. Let's look at part B. I have y squared minus 9. I recognize this as a difference of squares. Difference because we're subtracting, of squares because 9 is a perfect square. So I want the square root of each of these. And then I just get y minus 3, y plus 3. And let's make these guys blue. Okay, let's do our part C. We have y squared plus 4y minus 21. I'm going to make an x. I have negative 21 and 4. How about positive 7 and negative 3? Our a value is 1 right here, so I don't need to make a square. And I have y plus 7, y minus 3. Let's make these guys green. Okay, and then our last one here, part D. Let's do it right here. And I have y squared plus 5y minus 14. I'm going to make another x to factor it. Negative 14, positive 5. How about positive 7 and negative 2? The a value again is 1, so I don't need a square. And I get y plus 7 and y minus 2. And these guys were orange. Okay, great. We're ready to plug everything back in. So I'm going to do that over here. Give us some space. So in yellow, we've up top, I've got y times y plus 3. In blue, I have y minus 3, y plus 3. In green, I have y plus 7 and y minus 3. And in orange, I have y plus 7 and y minus 2. All right, great. We're ready to cancel, so I can get rid of y plus 3s. These y minus 3s will cancel, and these y plus 7s. So my final answer is y over y minus 2. Great. Let's look at our second and final example today. Make sure you pause here and write the original problem. All right, I see here that we're adding. And whenever we're adding and subtracting, we are more interested in creating a least common denominator. But my denominators are not form. So I need to go ahead and factor these guys. Let's call them A and B. All right, on A, I have 3x squared minus 6x. I can take out a 3x as a common factor, and we get x minus 2. Great. In part B, I have x squared minus 4x plus 4. I make an x to factor it. We got 4 and negative 4. How about negative 2 and negative 2? My value of A is 1, so I can just write x minus 2, x minus 2. Wonderful. Okay, let's put these back into the original problem. So I have 7 over 3x, x minus 2, plus x squared over x minus 2, x minus 2. So we notice they both have an x minus 2. This first fraction needs another x minus 2, and the second fraction needs a 3x. The least common denominator that we want is a combination of everything. 3x, x minus 2, x minus 2. All right, so this first fraction here needs another x minus 2. So we multiply by x minus 2 over x minus 2. And our second fraction needs a 3x. So we multiply by 3x over 3x. All right, so then I have 7 times x minus 2 over our new denominator, plus 3x times x squared over the same denominator. Okay, great. Our denominators are matching, so I can go ahead and put them as one fraction. So I have 7 times x minus 2 plus 3x times x squared over a single denominator. All right, now I'm going to distribute in my numerator, so 7x minus 14. This has an exponent of 1. When we multiply, we add exponents. So this is a 3x cubed. Great, there's nothing to combine up top, so we're just going to rewrite it a little more orderly from highest to lowest exponent. And denominator did not change. And this here is our final answer. All right, guys, that's everything for today. Thanks.